Okay, so welcome. And so now I will now proceed to begin with going over the solutions for this AMC. So first of all, huh? What? Okay, first of all, with that said, can everyone see this? Can everyone see the OneNote screen that I'm sharing?
Yep.
Yes?
Yeah, we can see
Okay,
it.
okay. So yeah, be starting. I'll keep the chat open then. Okay, come on, come on. Okay, there we go. So I'll be keeping the chat open as well. So if you have questions, you can either ask verbally or through chat. So this first question, what is 1 plus 2 over 3 plus 4 over 5? So we need to just remember our basic PEMDAS. So we just start from this inside. 3 plus 4 over 5 is equal to 15 over 5 plus 4 over 5. And this is just 19 over 5. And so 1 plus 2 divided by 19 over 5 is equal to 1 plus 10 over 19, which is 29 over 19. And that is choice option C. Yeah, some of these choices were made to see if anyone was paying attention. And so with that said, are there any other questions that anyone has or statements? Okay, if not, I'll be moving on to the second question. So can everyone see this one as well? I'll assume so. Yeah, so we have 3 x cats and 4 y dogs, where x and y are non-negative integers. What's the largest integer number of pets that a room with this many pets is not possible? So basically this is saying the smallest, sorry, not smallest, largest number that can be formed by adding or subtracting 3 and 4. So there's a pretty famous theorem called the Chicken McNugget theorem, and it just directly tells you that it's 3 times 4 minus 3 times 4, which is 12 minus 7, which is 5, which is B. Another way you can do this is just to test. So 7 is 3 plus 4. 11 is 3 plus 4 plus 4. 13 is 3 plus 3 plus 3 plus 4. And so C, D, and E all do not work. And then for B, you can just see that if you have a 4, then you need a 1, and that doesn't work. And if you have a 3, you need a 2, which is also too small. Yeah, what Fred said. So, and well, 5 is greater than 2, and you want the largest one. So with that said, let's move on to number 3. So yeah, okay. So a cookie costs $5, and a cupcake 2 times that, and so that would be $10. And so we want to find the number of pairs. So a cookie and a cupcake pair costs 5 plus $10, which is $15. So now you're trying to buy, yeah, what Fred is putting in the chat. So now you want to buy with $60. So $60 divided by $15 per pair is equal to 4 pairs. And that is choice option B. Yeah, or you can also solve it how Brian put it. And next up is number 4. So yeah. So this is number 4. And so Ankon has 3 alts and is Evan's friend, and DJ Mathman has 39 alts and is also Evan's friend. And then Evan also has 239 ODIS students who are all his friends, and from them, only 10 each have one alt who is also friends with Evan. So Evan has no more ALPS friends, and so we want to know how many ALPS friends he has total. And so each alt counts as a different ALPS friend, and everyone has one main account that is not an alt. So basically now we see that Oncon, he has 3 alts and 1 main account. DJ Mathman, we'll abbreviate to DJ, has 39 alts and 1 main account. And as for the Otis students, there are 239 of them total, each with 1 main account, and 10 of them also have exactly 1 alt account. Yeah. And so this sums up to 440 and 249, and this is 253. So adding them up is 293. Oh yeah. With that said, let's move on to the 5th question. So which of the following is the greatest? So one way you can do it is just by doing the A over B, C over D comparison, and then you just cross multiply A, D, B, C, whichever one is larger in here is the one that's larger in this one. Although that would clearly take quite a while. So instead, we can try to be smarter. So instead, we can see that for these numerators and denominators, the denominator is always 2 times the numerator plus 1 to do that. So what we do is we subtract half from each of these choices. Sorry, we subtract each of these choices from 1/2. So then what we get is 1 over 62, 1 over 66, 1 over 70, 1 over 74, and 1 over 78. And now the greatest choice is the one. Yeah, you can do it like that. And so yeah, so now you can do it like how Fred put it, but this is slightly more rigorous. And so after you subtract all these numbers from 1/2, this is what you get. And then now the greatest number is the one that leaves the least number when it's subtracted from 1/2. The reason is because like say you have 0, you're subtracting 0, or you're subtracting 1 from 2. Then this is 2 and this is 1. And so yeah, the smaller number after it's being subtracted is the one that was greater initially. So we can pretty clearly see that the smallest one here is 1 over 78. So that corresponds to the last option, E. And so now on to number 6. Okay, there we go. Okay, there we go. So yeah, number 6. So there are 4 students. They're sitting on a round table playing a game. So 1, 2, 3, 4. And they're either given an orange or an apple. And so someone with an orange is truth, and so with an apple is lying. So if someone with an orange, oh, sorry. And everyone said the person on my right has an apple. And don't forget, apples are lying. So if someone says orange, someone has an orange, the person on their right has apple. And so if the person with an apple says that the person, so let's just assume that this person is orange. Then the person to their right must have an apple. And that's because his statement is always true. And now this person with an apple says the person on his right or her right has an apple. But this apple holding person is lying. So they have an orange. This person has an orange. And so Now the same thing happens again, and this person has an apple, and this person has an orange, and that just confirms this. Yes. So that means that there are always 2 apples and 2 oranges, which is choice option. Wrong button. Okay. So next up is, oops. Okay, this. Okay, sorry. Please wait for a second. You're probably gonna see some weird things, but anyways. Yeah. Okay, that's all cleared up. Does everyone still see the OneNote screen? I'd like to confirm this before
Yeah.
Oh yeah, that's nice. So next up is number 7. So Bob and Charlie have ages that add up to 60. And in 5 years, Bob's age will be 6 times Charlie's age. And so we want to find the difference in their ages. So let Bob be B years old and Charlie be C years old. So right now we have that Bob and Charlie's ages add up to 60. So that just means that, oh, and these are their current ages. And so that means that B plus C is equal to 60. And in 5 years, Bob's age, which is B plus 5, will be equal to 6 times Charlie's age, which at the time would be C plus 5. And so we want to find the absolute difference between their ages. So we just want to solve this equation. So B plus C equals 60, and B equals 6C plus 25. So however you want to solve it, you can solve it using substitution or subtraction, various methods, either way. So I'll just show this through substitution, but you can also C plus 25 plus C equals 60 done by substituting this equation into there. Then 7C is equal to 35 because I just combined these two and subtracted this from there. And so then C equals 5. And then, so what that means is that B is equal to 55. And so with that said, the absolute difference in their ages is 55 minus 5, which is 50. And so, yeah, is the answer E. And next up is number 8. And if you have any question at any time, don't forget to just interrupt me or something, or just send a message through chat. And yes, so number 8. So next we have that we want to find the number of pairs of elements that can be removed from 1 through 9, such that the average of the remaining numbers is the same as the original. So first of all, we obviously want to find the average of the original. And it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 over 9. And yeah, you can either add up all these numbers manually or realize they can pair off. And so that just equals 5. And so next, what you do after this is you want to find the number of pairs of elements you can remove such that the average is now 5. So, well, clearly the average is 5. And actually what you can do is you can see that this pairing off is what's key in this problem. And so you can either intuitively think of it like this, like the pairing off, which directly gives you the answer of 4, or what you can do is just do the manual calculations. So the sum is 45 initially, and afterwards the sum is 35 because it's 7 times 5, which is 35. And so that means that the pair adds to 10. And so with that, you can easily see after a bit of casework that the answer is D, 4. And so next, yeah. Next on to next on to question number 9. Okay. Sorry that it's a bit cut off, but you should be able to tell that that's a question mark. So we are given that A% B is equal to this operation. So first of all, 3% 4 is equal to 2 times 3 plus 3 times 4, which is 6 plus 12, or 18. Next up, 18% 5 is equal to 2 times 18 plus 3 times 5, which is 36 plus 15, or 51. And that is option choice B. Okay, so next up is question number 10. So question number 10. So I just spent $90 to buy clothes. Oops, okay. And a pair of socks costs $1 each, a shirt is $4 each, and pants are $6 each. And they bought a total of 60 new items. So how many of them were socks? Okay, there may have been a bit of confusion here, but by socks, I meant how many pairs of socks. So assume that X socks were bought, Y shirts were bought, and Z pants. And so now we have that we know that I bought a total of 60 items, right? So that means that the number in total is 60. X plus Y plus Z equals 60. And so I also spent $90. So the number of dollars I spent on socks was X, the number I spent on shirts was 4Y, and the amount of money I spent on pants was 6Z. And this is equal to 90. And so what we do after this is we subtract these equations. And what we get is 3Y plus 5Z is equal to 30. And after this, we know that Y and Z are both greater than 0, so that forces Y to be 5 and Z to be 3. And so after that, with the answer X, the number of socks I just bought, which is X, is equal to 60, which is the number of total, minus 5, minus 3, which is 52. E. And so next, on to question number 11. Oh, what were you confused about? Oh, 11. Okay, I'll explain the solution and then I guess you can tell me what you were confused about, or you can say it now. So you have variables a, b, c, d that are integers such that 2 to the power of a times 3 to the power of b times 5 to the power of c times 7 to the power of d is equal to 1,800. So you want to find the value of a plus b plus c plus d. So the solution for this is going to be pretty short. So 1,800 is equal to 100 times 18. Well, the point of what we're doing here is to prime factorize this to basically turn this into a product of a bunch of primes, which are what 2, 3, 5, and 7 are here for. And so I'll just show you one possible method of doing prime factorization. So 100 times 1,800 is equal to 100 times 18. And this is 2 squared times 5 squared, because this is just 10 to the power of 2 times 2 times 3 squared. And this is 2 to the power of 3 times 3 to the power of 2 times 5 to the power of 2. And so, yeah. So now we're just directly comparing these two together. So you have that A is equal to 3, E equals 2, C equals 2, and D is equal to 0. So A plus B plus C plus D is just D, 7. And so next we're going on to number 12. So we want to find the number of ways. Oh. Huh? Okay, nothing bad's going on. Okay. Wait, so Fred, how'd you solve the question?
Okay, so I didn't, I was like 2 times 3 times 5 times 7, which is 210, but then, okay, it was like really dumb, so I don't really
I
want to
see.
explain.
I see. not realize that 7's exponent would be 0. Okay, yeah, so with that said, let's move on to number 12. So we have 3 blue balls, 2 red balls, and 1 green ball. And we want to find the number of ways to arrange them. And so balls of the same balls of the same color are indistinguishable. Oh, give me a second. Sorry. Okay, yeah, nothing happened. Nothing bad happened. Okay, yeah, so 3. Okay, sorry. Now it's all good. So 3 blue, 2 red, and 1 green, and balls of the same color are indistinguishable. So one of the ways you can do this is we have 3 blue, 2 red, and 1 green. I will just be increasing them in size instead of doing any other method of distinguishing. Although this should be clear enough. So now there's 6 possible places we can put the balls in the order. So the first, this one giant green ball, there's 6 ways. Let's say he goes here. And now these 2 red balls. So there's 5 ways to choose the first ball and 4 ways to choose the second ball. But then we need to divide by 2 because, sorry. And then we need to divide by 2 because the balls are indistinguishable. So if we place the first one here and the second one here, it's the same as placing the first one here and the second one here. And so there's 3 spots left and 3 green balls. So there's 3 blue balls left. And so we just put those wherever, kind of. And so that means that the answer to this question is just 6 times 5 times 4 times 1/2. And this is just 60A. And so, yeah, with that, let's move on to the next question, number 13. Oops, chat is now covering that. Okay. Okay, so the 10 digit 7 to the power of 2023. So 7 to the power of 2023. There are 2 ways to do this problem. The first way is to know a certain theorem that basically limits this to just that says basically that sorry, any a to the power of anything where it's mod 100 would just reduce this exponent, let's say x mod 40 mod 100. It's kind of advanced. And so the other way to do this was just kind of a rather lengthy way. Well, not lengthy if you actually did it, but yeah. So if you do it, if you list them out, it goes 7, 49, 43. And then after that, it goes 0, 1. And you can see that this just repeats again. 0, 7, so on. So we can see that the 10 digits will clearly either be 0 or 4. And so it's 2023. So this is 7 to the 1, 7, 2, 7, 3, 7, 4, and then 7, 5. So this cycle repeats every 4. So 7 to the power 2022 goes to 0, 1. And after that, you can start counting. So this is 7 to the 2021, 7 to the 2022, and then 7 to the 2023. And so the answer is 4D. And so next up, we'll go to number 14. Oops. So we want to find the number of ways to split 10 donuts that can't be divided by further and you can't tell them apart between 4 different kids. So you can just do this doing stars and bars, and it's 13 choose 3. Of course, Some of you probably don't get what I just said, so I'll explain this. So basically we have 10 donuts, right? 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 4 kids, which we can treat as 3 dividers. And the reason I say 3 is because the first kid is to the left, the second kid is here, the third kids are here, and the fourth kids are here. So yeah, that's why there's 3 dividers. And so basically we want to find the number of ways to arrange this on a line. 1, 2, 3. So now there are 13 spots here because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so we can do 13 times 12 times 11 to choose the number of spots for these 3 sticks. But now we need to divide by 3 factorial because that's just the number of ways that we can have these sticks be indistinguishable. Basically what I mean is like you can place a stick here, here, and here, but it looks the same as if you place the sticks here, here, and then here. And so there's 6 ways total to do that mess up for each possibility, and so you need to divide by 6. And these two are numerically the same thing. So this is just, after this, you just calculate, and it's 286. If you want to see how to calculate this fast, it's 13 times 2 times 11, which is 26 times 11, and then 26 is 286. So yeah, the answer to this question is B. And so next up, question number 15. Okay. So 15. So you have, a trapezoid ABCD. Oh, that's kind of bad. A, B, C, D. You know what? This is fine. A, B, C, D. So this angle is 135, and this angle is 45, and this angle is 90. So the sum of the angles in any quadrilateral are always 360. And it's very similar to how the sum of the angles in a triangle is 180. So then we have that this angle is equal to 90. And that's by subtracting these numbers from 360. And so now we have that AB is equal to 6. Oh, sorry, I wrote these in the wrong order. Okay, let me get this again. A, B, C. Okay, so this is 6, and these two are equal. Okay, this a little. I'm amazed no one noticed. Okay, but at any rate, okay, I'll give you what the problem was intended to be. BC is equal to 6, and AB equals AD. Okay, this problem, I don't know what happened to it, but yeah, this problem. So why did no one ever, yeah. So why did no one ever raise any questions? This problem was, no, this problem was completely wrong. Okay, okay, well, yeah, okay. I guess, no, it's not. Okay, well then, why did no one bring up a complaint if everyone realized that something was wrong? Okay, Okay, wow. Okay, well, at this rate. Anyways, so yeah. So this is what the problem was meant to look like originally. So yeah. So this is 135, this is 45. Okay, and I've already stated before that these are both 90 degrees. So yeah, so we want to find the area of this trapezoid. So first of all, we can see that let's just drop a 90-degree angle from B to CD and call this point E. So now we'll look at this triangle BEC. So it's 45, 45, 90. And so this is 6. Yes. Okay. Sorry about that. Let me check the version I have. Oh, okay. Anyways, and please don't spam the chat. I'll probably drop the question, but yeah. I'll probably have this question dropped, but yeah. A typo, a bit of typos. Yeah. Sorry about that. So yeah. Okay, so anyways. Yeah, no, this question is completely impossible if you do it as is. So I don't know. So yeah. So this is 45 degrees, and this is 45 degrees. So this is a 45, 45, 90 triangle. And so you're dividing 6 by 3 by square root of 2. And so you're getting 3 root 2 and 3 root 2 here. And so now let's look at A, B, E, D. So I have these two are equal and these two are 90 degrees. And this is also 90 degrees because this is 180 minus the 90-degree angle. With this problem will probably be dropped, Riton. And so this angle is also 90 degrees. So ABED is a rectangle. And then so we also have that these two are equal. And so that means that ABED is actually a square. And so now we'll already have that this is 3 root 2. So this is 3 root 2 as well. And so this whole area is 3 squared times 2, which is 18. And this question here, sorry, this triangle here has area 3 root 2 times 3 root 2 over 2, which is 9. And then you add these up to get C27. Okay, hold on a second. Okay. Okay, it doesn't matter. And then it doesn't matter if you guessed it right or not. It's getting dropped. So people who guessed it right are just going to be sadder. Okay, oops. Okay, 16. Okay, so we have a 2020 Football for Life conference. So each team plays every other team exactly twice. So a total of 72 games were played over this conference. So we want to find the number of teams total. So yeah. Okay, you guys can stop cheering in the chat, I guess. Yeah, what Fred said. So basically, we'll take a look at, let's say, team A. So let's have there be n teams total. So then team A plays against n minus 1 teams twice. So team A and team A's situation is not unique or anything. So in total, from the perspective of each team, there's a total of 2n times n minus 1. Yes, what Fred said. There's a total of 2n times n minus 1 games played, but this double counts because each team each game is counted twice, once from the perspective of each side. And so this means that the number of games total played is actually n times n minus 1. And this is equal to 72, so n is equal to 9. And that's B. And if you can't solve this on your own, you can always just go back to the choices and start plugging them in one by one after this point. So next up is question 17. So question 17, all this kind of did was test if you knew. So if you don't, the divisibility rule is that the sum of the digits, sum of. If the sum of the digits is a multiple of 9, then the number is divisible by 9. And I won't prove why this works because the proof is a bit long and there are simple methods, but I don't really want to cover them because I have to do more explaining as to how the methods work. So as for now, you can just take this as like a given. So now this first number, 2 plus 7 plus A plus 4 plus 5 plus B plus 1. So this 2 plus 7 and this 4 plus 5 both cancel because they're all divisible by 9. And by our 9 divisibility rule, we can basically ignore anything that's not already guaranteed to be a multiple of 9. So now we have that A plus B plus 1. Ooh, what happened here? B plus 1, okay, is divisible by 9. So basically A plus B is 8. A plus B can be considered to be equal to 8. 8, or it could be 17. Larger numbers won't make a difference. Sorry, larger numbers are impossible to reach anyway, so it's 8 or 17. But for convenience, we can just make it 8. And now I have A plus 2 plus 2 plus B plus 9 plus C plus 3 is also divisible by 9. So now we have that this 9 is ignorable. A plus B is equal to 8, or we can treat as equal to 8. So now we have 8 plus 2 plus 2 plus 3 plus C is equal to something that's divisible by 9. So this sum is equal to 15. 15 plus C is equal to, well, at this point you can see that it's either 18 or 27 because, yeah. And so if you subtract, you can see that C is equal to 3 or 12. This 12 is clearly too big. So the answer is B, 3. So next up is question number 18. It was kind of a nice question that was very simple. So we have A and B such that A cubed plus B cubed is odd. And if so, if we have that, then which of these are possible? So if A, so if you already kind of give me a second. Okay. Okay. I'll assume that everyone can hear me. So yeah, so the answer is D. I'll just give this off the bat. And so okay. Um okay, sorry about that. I hit my Okay, can all of you see the OneNote screen? I'd like a response some way, somehow, please. Okay. Yeah, okay, all of you can see it. So number 18. So I'll just give right off the top of the bat that the answer is D. And so now I'll show why that's true. So if we have that A and B are even, then A cubed will be even, B cubed will be even, so the result will be odd. And so if A and B are both odd, then A cubed plus B cubed is odd plus odd, which is still even. And now if A plus B is even, what that implies is either A and B are even, or A and B are both odd. And we've already shown in option A and B that neither of these work. So then the answer is either D or E. And if you want, I can show an example for why D works. So let's say A equals 0 and B equals 1. Then A cubed plus B cubed is just 1. And yeah, that works. So yeah, if you wanted, you could have also just tried variations of A equals 0, B equals 0, A equals 1, B equals 1, or A equals 0, B equals 1, and you would have eventually seen that this worked. So this problem wasn't really that bad, especially for an 18. And so now next up is question number 19. So yep. So this kind of tested expected value, which is something that usually probably will not appear on the 8s. But regardless, MA doesn't really care about that anymore, I think. So yeah. So you have a game that's as follows. So you're rolling a 6-sided die 3 times, and you get $1 if it's a 1, $2 if it's a 2 or 3. Oh, sorry, $2 if it's a 2, 3 if it's a 3, and so on. So basically, you want to set you want to find the entry fee such that you have an expected 50% profit. So this is testing the concept of expected value. And so expected value, so basically it's just the sum of probability of an event times value of events. So for instance, the probability, yes, that's right, Fred. And so basically for something like the expected value of a dice roll, you have 1/6 times 1 plus 1/6 times 2 plus 1/6 times 3, all they do 1/6 times 6. And if you do the sums, it's just 3.5. And so now, as for applying this expected value to this problem, there's a 1/6 chance that you roll a 1, which gets you $1. 2/6 chance that you roll a 2. Sorry, 1/6 chance that you roll a 2. And then 1/6 chance you roll a 3, and so on. And this is the same as just a normal dice roll. So yeah, the expected amount of money you earn is 3.5 per dice roll. And so you're rolling this 3 times, so you get 3.5 times 3. And so the expected value is 10.5. And yeah. So this the thing you just did here, multiplying by 3, can be generalized to something called the linear expectation, but that is probably way beyond anything you'll ever see on the 8s. So I won't go over what that is. Just know that basically expected value can be treated as like linear values. And so you want a 50-cent profit, right? So you just need to add another 0.5 to this and you get 11, which is A. And that is number 19. So now let's move on to number 20. Okay, why?
We have a question.
Okay, yes. Which question?
Usually for like 20 to 25, I don't have time, so I just guessed all the problems like from
Okay.
20 to 25. Is that fine?
If you don't have time for 20 to 25, that's about fairly normal, I'd say. Like you don't see many people getting a perfect score or anything like that. And generally, like I think you get like recognition for like I think roughly 20s. You get like some kind of like top percentage award. I don't know where the cutoff is, but it's it's not that bad. So yeah, being able to soften the 20, I haven't taken the 8 in a long time, so I can't remember. But like, yeah, if someone else knows, they can always talk about it. So yeah, so 20. So an equilateral triangle and a square have equal areas. And so the perimeter of this square is 2, and we want to find the perimeter of the triangle. Yeah, I think, yeah, that sounds about right, I think, Elaine. So the perimeter is 2. So, and at this point, I'll kind of speed up since there's 6 more questions that I need to cover in 15 minutes. So yeah, I'll kind of speed up. So the perimeter of the square is 2, so that means that each of these sides is 1/2. And so we know that they have equal area, so the area of this square is 1/4, so the area of this equilateral triangle is 1/4. And so now to find the area of an equilateral triangle, let this side be S, and then this is a 30, 60, 90 right triangle. So this is S over 2, and this is S root 3 over 2. And so the area of this triangle is S squared root 3 over 4. And the reason I didn't divide by 1/2 after multiplying these two is because there's another one here with the same area. So this is equal to 1/4, so S squared is equal to 1 over root 3. So S is equal to 3 to the power, and this is 3 to the power of negative 1/2. So S is equal to 3 to the power of negative 1/4. And so the perimeter of the triangle is just 3S, which is 3 times 3 to the negative 1/4, which is just 3 to the 1 minus 1/4, or 3 to the 3/4. And that is option choice. Sorry, that is option choice C. So next up is question number 21. So we have a standard 52 card deck, and Alex is drawing 4 cards at random without replacement. So we want to find basically the probability he draws exactly 3 5s. So okay. So yeah. So now we can ignore the order which the cards are chosen in the numerator and the denominator. So in the numerator, you have choose 3 ways to choose the 3 of the cards. Which 3 of the 4 5s are chosen here? That's very sad. I'll assume here that everyone here understands how a standard 52 card deck. If you don't, you can always just search it up on your own. 3 ways to choose which 3 of the 4 5s are chosen. And then there are 52 minus 4 possible cards for the last one. Here, because we are excluding the 5s. And the number of ways which you can choose for cards is just 52 choose 4. And so this is just, oops, I forgot to add parentheses here. So this is just 4 times 48 over 52 times 51 times 50 times 49 over 24. Or it might be better to express this as 4 times 3 times 2 times 1. So this is 4 times 48 times 4 times 3 times 2 times 1 over 52 times 51 times 50 times 49. And so now it's just a bunch of cancellation. So this 4 and this 4 cancel. This 2 and this 2 cancel. This 3 and this 3 cancel. And then so yeah. All that's left in the numerator is 4 times 48 over 13 times 17 times 25 times 49. So the numerator is just 4 times 48, which is 192. And that is choice option C. So next up is question number 22. And so number 22. Oops, where is it? Okay. Number 22. So a club tries to take a picture of their members every day in January in a rectangular formation. So they also want to Okay, can you hear me now? Okay, yeah, Zoom shows my microphone. Oops, okay, yeah. So rectangular formation means something like this. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, something like this. Assume that these are all straight lines, of course. And so now they want to make that every day there's a different number student at every row, but by January 17th, they find themselves unable to do so. And so that means that they had available numbers on first, second, third, all the way to the 16th. And so basically all this is implying is that this is a number with exactly 16 factors. Well, 16 factors, and of course, non-proper, because this includes the number itself. And so basically, the choices were very kind, and the answer is A, and that's 2 cubed times 3 times 5. This is 4 times 2 times 2, which is 16. And yeah, the choices were pretty kind for this one. So yeah, 22, the answer is A. 23. So we have a rectangle that's, So we have this rectangle and it's rotated 180 degrees clockwise. So basically it covers something like this. And this part. Basically, it just forms a whole circle. That's basically all this problem is saying. And that, I think, was kind of the understanding what exactly is going on. And so basically, yeah. Oh, and this is pretty badly out of proportion, but I hope no one minds. So this is a 16 by 30. So this is 15, 15, 8, 8. So the radius of the circle, so the circle is centered, okay. I'm definitely not here to just look at your answers. In fact, I'm not even really paying attention. Anyways, so yeah, so there's no point in doing that. So yeah, so I'll just hurry up a bit. So basically, this circle is centered at the center of the rectangle. So the radius is just the distance from the center of the rectangle to one of the vertices. And so this is 8 and 15. So by the Pythagorean theorem, the radius is 17. So then the area equals pi r squared equals pi times 17 squared, which is 289 pi. And so 20, didn't get the whole problem. Okay. Why? Okay, please wait. There is some difficulty in getting a screenshot. There we go. Okay, so now we have a quadrilateral ABCD, and you have AC and BD are perpendicular. So A, B, C, D. And this is perpendicular. AB is 6, BC is 9, CD is 13. And we want to find AD squared. So we can let these sides be A, B, C, and D from this point of intersection to the vertices. And so now we have A squared plus B squared equals 6 squared, B squared plus C squared equals 9 squared, and C squared plus D squared equals 13 squared. And this is by the Pythagorean theorem. And what we want to find is A squared plus D squared. And the way we can do this is it's A squared plus B squared plus C squared plus D squared minus B squared plus C squared. And this kind of stuff is actually fairly common to see. So yeah, if you ever see something like this, I guess now you know how to do this. So yeah, so we have that this is 6 squared plus 13 squared minus 9 squared. And this is 36 plus 169 minus 81. I won't explain how to do this quickly because there's no good way, or rather, there's no point in doing this fast. And the answer is just C, 124. And it's now a last problem. So number 25. We have 2 points chosen at random on the same side of a square, and a third is chosen at, this is not a square, but treat it like one. And a third is chosen at random on one of the other 3 sides. So let's say here, or here, or here. And you'll understand why I drew 3 soon. So I want to find the probability to make an obtuse triangle. So first of all, these 2 points are placed randomly on one side. So the probability that if the third point is on one of these 2 sides, I'll mark it in blue, one of these 2 sides, then it's guaranteed to be obtuse because it would end up looking something like this. And so now, if the point chosen is somewhere here, then it's once again obtuse, like this. But now, if the point is chosen between the 2 points on the opposite side, like this, then the triangle is acute. And that is the only chance that the triangle is acute. And so basically, we want to find the average chance that a point lies between a random point lies between 2 random lines. Sorry, 2 random points on a line. And so you can do a symmetry argument, and it's like the 2 points the line into 3 equal parts on average, or something like that. So yeah, you can use a symmetry argument. And so the probability that 2 points, so this is, sorry, I should probably specify that this average chance that a random point lies between 2 random points on a line is just equal to expected length of segments between 2 random points on. Okay, yeah. So now you can use the symmetry argument, and you can see that this expected length is just exactly 1/3. And so that means that if the third chosen point lies on the opposite side, there's a 1/3 chance of acute. And don't forget that this is a 1/3 chance initially of being on the opposite side because there's 2 more sides here. So this is 1/9 chance of failure. So the answer is just 1 minus 1/9, which is 8/9. And that is option choice E. And that's the solutions for the whole test. So yeah, thank you. Are there any questions about anything that I just went over?